Examination questions on hyperbolic functions, the graphs of this type of functions. This is one of the areas I think in mathematics paper 1 we can be able to get full marks with no problems. So it asks normally the most obvious things. We know that if our equation is given as f of x is equal to a divided by x minus p and then plus q, in this equation, the first thing to notice is we must know very well how to determine the equations of the asymptotes. So the asymptotes, the first one comes from equating the denominator to 0. So x minus p is equal to 0. That gives me x is equal to p. Then the second one comes from equating f of x to q. That's y is equal to q. These are the two asymptotes of the function, and I need to know that in general from my studying, which means in this case, if I equate x plus p to 0, I must get the first asymptote, then y is equal to q will be my second asymptote. The next thing that is being tested here that I need to know how to determine the coordinates of the x and y intercepts. That will be coordinate b. So b is the y-intercept of the function. So the question will be, how do you determine the y-intercept? For us to find the y-intercept, we put 0 in place of x and then solve the resulting equation. The next item important being tested here is how do you find the equation of a straight line? Number 3, we need to find the equation of g, which is the straight line passing through points A and B. So point A is -5 and -2, and point B is the y-intercept of the function that we have calculated in number 2, which means our question number 2 must be very much correct. The line AB itself is not shown. If you so wish, you can draw the line yourself and make sure that it's a line from A to B. Then we need to find the equation of that line. So the equation of a linear function in general is y is equal to mx plus c. And in this equation, m represents the gradient and then c represents the y-intercept. So which means for us to find the equation of line AB, we must know what the gradient is. We may have to calculate the gradient using the gradient formula. Then in question number 4, where there are 5 marks, it says determine the coordinates of the other point where f and g intersect and show your working out. Where two graphs intersect each other, they are equal at the point where the graphs meet. So that means f of x will equal to g of x. You equate the equations of the graphs and then solve the resulting equation to determine the x values that are needed for the graphs to cross each other. That is what we are given in this question, and those are the ideas that are being tested. So let's have a look at the answers to this question. Okay, let's have a look at the answers to this question. We need to find the values of p and q. So in this case, p is equal to 5 and q is equal to 2. Just to quickly emphasize, the denominator of our fraction is what gives us the vertical asymptote. We equate that to 0. X plus p is equal to 0. Then the value of x is the x coordinate which is given at the asymptote. So in this case, x is equal to -5 is the value of the vertical asymptote. Y is equal to -2 is the horizontal asymptote. So if you put the value for x here, which is -5, you get -5 plus p is equal to 0, which gives us p is equal to +5. Now that is where p is equal to 5 is coming from. The value of q comes directly as it is. Q is equal to -2. B, number 2, the coordinates of B. B is a point where the graph is crossing the y-axis. To find the y-intercept, we replace x with 0. So in the given equation, if you put 0 in place of x and work out the answer, that is how we find the coordinates of point B. Question number 3, very much interesting. The general equation of a straight line is y is equal to mx plus c. In this equation, c is the y-intercept. Because the line is passing through point B, it therefore follows that the value of c from point B, which is the y-intercept, is minus 8 over 5. So we can immediately put minus 8 over 5 in place of c. If we do that, all we are left with is the gradient of the line. The gradient is calculated using the gradient formula. Once we find the gradient of our line, we can safely conclude that the equation of the line is y is equal to 2 divided by 25x plus c, which is minus 8 divided by 5. This is the equation of the graph of G. In the event that the y-intercept is not given and we are not able to read it from the equation or from the graph, then we can calculate it in the same way, in this following way. After reaching this level, we find the coordinates of one point which is on the line that we are calculating. In our case, there is point A, which is minus 5 minus 2, and there is also a point B, but let's say point B is not given. Then we can find C by substituting these two numbers into the equation. The first one is for x, and the second one is y. So if we do that substitution, putting minus 2 in place of y and minus 5 in place of x, that allows us to calculate the value of c and then conclude that the equation of g of x is equal to 2 over 25x minus 8 over 5. But in this question, because the value of c is given, we can write our answer straight away and skip this working out. Number 4, we want to find the coordinates of one point where the graphs meet. Why is the question saying find the coordinate of the other point? It's because one point is already given. The straight line the line AB is crossing the graph at point B and also at another point. So what we need to calculate now is another point where the graph is crossing the line besides B. Now, the concept that we have here is that whenever two graphs are crossing each other, we find the coordinates of where the graphs meet by equating the equations of the graphs. So f of x is equal to g of x. So in my case, this first part of this expression is the equation of f of x. And the second one there is the equation of g of x. F of x is equal to g of x. Then I must solve that equation to determine the required values. So carrying on, these two here and this 8, they are both constants. So we can add them, bringing the 2 to this side. It will become plus 2. That will be 2 plus minus 5 over 8. It gives me 2 over 5. To solve an equation that is fractions, we must multiply each fraction by a common denominator or by the lowest common multiple of the fractions. In my case, the lowest common multiple is 25 multiplied by x plus 5. So I'm going to multiply 25 times 25 factor of x plus 5 by each fraction to remove the denominators. So the first one, if you multiply x plus 5 and x plus 5 cancel, I remain with 25 times 2, which is equal to 50. In the second one, 25 cancels 25. I'm going to remain with the 2x factor of x plus 5. Then in the next one, 5 divides into 25 5 times. 2 times 5 will give me 10. So this part is going to remain with the 10 factor of x plus 5. Then I can write that down and carry on with my calculation. 15 is equal to 2x factor of x plus 5 plus 10 factor of x plus 5. Now this is multiplication that I have to do to remove those brackets. If I multiply there, this is what I now have. Then collecting like terms, if we transpose the 50 to this side, it's going to become 50 minus 50, which gives me 0. Then these are like terms, 10x plus 10x, that gives me 20x squared. Now I have 0 is equal to 2x squared plus 20x. This is a quadratic equation that I must solve. If you have done quadratic equations very well, you should be able to remember that if there are only two terms, we can safely factorize our equation. The common factor is 2x factor of x plus 10 is equal to 0. Then the 2x equals to 0 gives us x is equal to 0. X plus 10 gives us x is equal to negative 10. These are the two x values where the graphs meet. This one is for point B. At point B, the coordinates of B are 0 and negative 8 over 5. This is the 0 that we got. So we want the other coordinate, which means we must find the value of y when x is equal to negative 10. You go back to the equations, the linear one preferably because it's shorter. Then in that equation, we replace x with negative 10. So 22, this is the equation that we're using. Now 2 over 25 times x will become 2 over 25 times negative 10 minus 8 over 5. Then we simplify. This will give us negative 2 and 2 over 5. That is the y coordinate. So the two graphs are crossing at this particular point. If you look at this calculation again, you should be reminded of simultaneous equations that come in question 1. We solve the graphs simultaneously to be able to determine the answers that are required here. Then our question is answered.